Okay, introduction to radicals. So first I'm going to talk about perfect squares, perfect cubes, and perfect fourths. So what I mean by a perfect square is that you could take the square root of it. So examples of perfect squared are 1 squared, 2 squared, 5 squared, 11 squared, etc. What this means is that I could take the square root of 121 and I would get 11. I could take the square root of 9 and I would get 3. Same with perfect cubes. I could take the cube root of 64 and get 4. I could take the cube root of 512 and get 8. And then with perfect fourths, I could take the fourth root of 625 and get 5, or the fourth root of 16 and get 2. Notice on the top of each of them, it's mentioning what kind of numbers we would get. So perfect squares, it's only positive numbers. Same with perfect fourths. And then perfect cubes, it could be negative numbers. Okay. Parts of a radical. So first we have the index. And the index tells us what kind of radical it is. So it's that little number above the radical sign. So if this was a 2, then it would be a cube root. If it was a 3, it would be a cube root, so on and so forth. Okay. This is called the radical. Okay. So no longer call that the square root. Call that the radical, because we're talking about multiple different radicals now, not just square roots. And then we have the radicand. So the radicand is the number inside of the radical. Okay, so simplifying radicals. So in order to simplify square roots, remember square roots have an index of 2. We have to simplify pairs of numbers multiplied. Okay, for cubes root, that's the same as saying index of 3. We simplify groups of 3 numbers multiplied. And for fourth roots, that's the index of 4. We simplify groups of 4 numbers multiplied. For example, in order to simplify the square root of 117, we know that the square root of 117 is the same as the square root of 9 times 13. And we know that we can take the square root of 9 and separate it from the square root of 13. Because the square root of 9 is 3, and the square root of 13 does not have a perfect square, so we simplify this to say 3 square roots of 13. Okay. Now we have 2 cube roots of 48. So I'm going to show you another way we could do this. So that's one way, finding 2 numbers that multiply to the radicand. Another way is to do the prime factor tree. And we did this a little bit in earlier units. So remember, with the prime factor tree, we're going to take prime numbers and we're going to divide into our radicand. So starting with 2, 2 goes into 48 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. And 2 goes into 6 3 times. Since this is a cube root, we're going to circle pairs of 3s. So here's one pair of 3, and then notice we don't have any pairs left over, which means that 2 is going to come out. So we have 2 cube root, and then that 2 and 3 that are left over, we're going to multiply them together. So 2 times 3 is 6, and then we can't forget about this 2 that was in the front to begin with, so we have to take that down and multiply it by the 2 that we took out, so 2 times 2. So we have 4 cube root of 6. And then the same thing with the fourth root. So I'll show you again the other way. So 2 numbers that multiply to 162. Well, that is 81 and 2. So this is 3 times the fourth root of 81 times 2. Okay. We can take the fourth root of 81 because it's a perfect fourth. So we would do 3 times the fourth root of 81 times the fourth root of 2. The fourth root of 81 is 3, so this is 3 times 3 times the fourth root of 2. So we would have 9 fourth roots of 2. Okay. We could also see negatives. Remember, if we see negatives, then we should be dealing only with the cube root. Okay, so let's look at this one here, and I'm going to do the prime factor tree. Remember, I'm showing you 2 ways you could do this. Prime factor tree, I'm going to start with 2. 2 goes into 250, 125 times. Okay, and right now I'm ignoring the negative. And then let's see, 2 doesn't go into 125 anymore, so we have to check the next prime number, which is 3. Okay, so 125 divided by 3, that doesn't work, so check 5, the next prime number. 125 divided by 5 is 25, so 5, 25, and then 5 and 5. Then we circle pairs of 3, since this is the cube root. We only have one pair of 3 right here, and that's 3 5s. That 5 is going to come out, okay, and the 2 is going to stay in, so 5 cube roots of 2. And that negative, remember I said we were going to save that for last? That negative is going to come out with our 5. So this answer is negative 5 cube roots of 2. Now, let's start bringing in some variables, okay? So when we have variables in here, in order to simplify this, we're going to treat this almost like 3 separate equations. So I'm going to say that this is the square root of 32, the square root of x to the 4th, and the square root of y to the 9th. Okay, I'm going to do the prime factor tree on 32. So this is 2 goes in 16 times, 2 goes in 16 8 times, 2 goes into 2 goes into 8 4 times, and then 2 goes into 4 2 times. Since this is the square root, I'm going to circle pairs of 2. So this looks like I have 2 times 2 square roots of 2, which is 4 square roots of 2. Okay. Now I'm going to do the x's. Okay. So I could do this one of 2 ways. I could say, okay, the square root of 4 is 2, so that means I'm left with x squared. Or I could say, okay, x to the 4th, this means I have 4 x's. 1, 2, 3, 4. And since it's the square root, I'm going to circle pairs of 2. 1, 2. Well, I have 2 pairs of 2, which means I'm taking out an x squared. And then y to the 9th, I could do, okay, the square root of 9 is 3. Sorry, I'm looking at the answer key and I realized I have my answer key wrong. Anywho, let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 y's. I'm going to circle pairs of 2's. 1, 2, 3, 4. So I have 4 pairs of y's, which means I have y to the 4th. Oops. Y to the 4th. And I have 1 y left over, which means that's going to stay under the square root. So if I was to combine my answer, I take all the numbers that are on the outside, so 4, x squared, y to the 4th, and I'm going to put them together. 4x squared, y to the 4th, and then everything that is left under the radical, I'm going to combine it. So 2 and y is the square root of 2y, and this is my answer. Okay. Number 6. We have the cube root of negative 81 p squared times q to the 12th. I'm going to separate this into 3 equations. So this is the cube root of negative 81 times the cube root of p squared times the cube root of q to the 12th power. Okay. I'm going to start with my 81. So 81, I know 2 can't go into it. Let me check 3. 81 divided by 3, I get 27. So this is 3 and 27, 3 and 9, and then 3 and 3. Since this is the cube root, I'm going to circle pairs of 3. So that means I have 3 cube root of 3 to simplify for this one. And since it's negative, I'm bringing the negative on the outside. Okay. Now I'm going to do p squared. So p squared means p times p. And notice I can't circle a pair of 3 because I only have 2 there. So this has to stay the cube root of p squared. And then now with my cubes, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to circle pairs of 3. So 1, 2, 3, and then look, I have another one over here. So I have 4 pairs of 3s, which means I can take out q to the 4th power with nothing left over. Okay. So what I would be combining is everything on the outside first. So that's that -3, nothing for this one, and then q to the 4. So I have -3 q to the 4, and then everything under my cube root is going to stay together, 3p squared. Okay. Now let's look at the next part. So the next part says converting exponents to radicals. Rational exponents are radicals. For example, a to the m divided by n power is the same as saying the nth root of a to the m power. Your numerator is the exponent inside the radical. So here's where it's important. The numerator is the exponent inside, and the denominator is the index of the radical. So this one's the index, and this one is the exponent inside of the radical. Think exponent over index. Exponent over index. If there is no index, then we assume that it is, okay, so if there's no index, we assume that it is 2. So if you have the square root of, x, if there's nothing there, we know that that index is 2. Okay. It says write the radical expression in exponential form. So it wants us to change this to where it's x to the power of something. Okay. So instead of the 4th root of x to the 7th, we would take x to the 7th divided by 4. Okay, so again, this denominator is our index, and this exponent is our numerator. That's where it came from. That's our answer. Okay, now let's do the opposite. X to the 3/4 means this is the 4th root of x cubed. Okay, again, this exponent was our numerator, and this denominator was our index. Rewrite the radical expression in exponent form. So first, let's try to simplify this. So I'm going to simplify this as the square root of 18 times the square root of x. I can simplify 18 by doing the prime factor tree. So I have 2 and 9, and then 3 and 3. Since this is the square root, I'm going to circle pairs of 2. So that means this simplifies to 3 square roots of 2. And then I can't really take a pair of x's because I only have one x there. So I would bring down that square root of x, which means this is 3 square roots of 2x. Okay. So in order to write this in exponent form, I have to look at the index. So the index, remember, if we don't see any, is 2. And our exponent, again, if we don't see any, is 1. So then this is the same as saying 3 times 2x to the power of 1/2. And we're going to make sure to put that 2x in parentheses so we know that the 1/2 exponent is going to the x and the 2. Okay, now it says rewrite the exponent in radical form. We have 2x to the 2/3. Okay, so we would write this as 2x, and the exponent is the numerator, so that would be squared. And then the bottom one is the index, so that would be cube root. So it's the cube root of 2x squared. We could even simplify this further and do the cube root of 4x squared. So all I did was give the square to the 2 and to the x. Okay, now let's add some variables back into here. So it says simplify the expression. Okay, so 63x squared, y to the 5th to the 1/2 power. Okay, when we have an expression like this, all raised to 1 exponent, we can give that exponent to everything inside of the parentheses. So think of us distributing it, but we're not multiplying. And you'll see why in just a second. So I'm giving that 1/2 exponent to 63, to x, and to y. So that means this is 63 to the 1/2 power times x to the 2 times 1/2 power and y to the 5 times 1/2 power. Okay, so that means this is the same as saying 63 to the 1/2 times x, because 2 times 1/2 is 1, x to 1 power is just x, and then y to the 5/2. Okay, so we would convert this, and since they both have that denominator of 2, that means they're under a square root. So right now we have x times the square root of 63y to the 5th power. Okay, so we would have to simplify this. In order to do that, I'm going to do the prime factorization on 63. Well, 2 can't go into 63, so I check 3. 3 goes into 63 21 times. 3 goes into 21 7 times. This is a square root, so I can circle pairs of 2. So I'm going to be taking out a 3. And I'm going to do the same thing with my y. So I have 1, 2, 3, 4, 5. I'm going to circle pairs of 2. And I can take out 2 y's here. So I have 3xy squared times the square root of 7, because that's left over, y. That's my answer. Okay, same thing here. I'm going to give that 1/2 power to every single component. So this is 49 to the 1/2 power, z to the 6 times 1/2 power, and y to the 7 times 1/2 power. So this is the same as saying the square root of 49. This is the same as saying z to the 3rd power, and this is the same as saying y to the 7 over 2. So we know that the square root of 49 is 7. Okay, z cubed doesn't have anything under the radical, so I'm going to bring that down. And then this, since this is 7 over 2, tells us that this is the square root of y to the 7th. But we should be able to simplify that even further. So if I draw out my 7 y's, I can circle pairs of 2. And so 3 of my y's are coming out. So this is 7z cubed y cubed square root of y. Okay, same thing. So I have 120 to the 1/3 power, a to the 5th times 1/3 power, b to the 3rd times 1/3 power. So 120 to the 1/3 power, that's the cube root of 120. A to the 5th times 1/3 power is a to the 5/3, which means this is the cube root of a to the power of 5. And then b to the power of 3 times 1/3 is 1, so this is just b. Okay, now I have to see if I can simplify. So I can do the prime factor tree on 120. So this is 2 and 60, 2 and 30, 2 and 15, 3 and 5. I can circle pairs of 2's. 1, so I have only 1 pair of 2. So that means I'm taking out a 2, and left inside my square root are all these numbers multiplied together. 2 times 3 is 6. 6 times 5 is 30. That doesn't seem right. 120, 260, 230, 215. Can't use 2, so I jumped to 3, 3, 5. And I'm supposed to multiply them all together. Oh, nope, that's correct. So 30. Okay. Here I have 5 A's. I can circle. Oh, that's where I messed up. Okay, this is the cube root. So if it's the cube root, I have to circle pairs of 3. Okay, this is a common mistake that can happen. Okay, so that means I have 2 cube root of 15. That makes more sense. Okay, circling pairs of 3's for my A. So I have 1 pair of 3. So I have A cube root of A squared because I have 2 A's left over. And then I just have B. Okay, so everything I took out is going to come out. So this is 2AB. Cube root of everything inside stays inside, 15A squared. Last one. I have negative 50 to the 2/3 power, x squared times 2/3 power, and y to the 7th times 2/3 power. Okay, so negative 50 to the 2/3 power means this is the cube root of negative 50 squared. Okay. X to the 2 times 2/3 power is x to the 4/3 power. So this is the cube root of x to the 4th. And y to the 7th times 2/3 power is y to the 14/3 power. So this is the cube root of y to the 14th. Okay. Let's see. 50 cubed is 2,500. So this is the cube root of negative 2,500. So I'm going to do the prime factor tree on that. So if I start with 2, let me get out my calculator. So 2 is 1,250. If I try 2 again, I get 2 and 6, 25. 2 won't work anymore, so let me try 3. Okay, 3 doesn't work. 625 divided by 5. So 5 and 125. So 5 and 25, 5 and 5. And I have to circle pairs of 3 because it's the cube root. Okay, so I have 1 pair of 3. Right, 10. Hang on, I think I did something wrong. Let me just double check. So 50 squared, yeah, divided by 2. Okay, divided by 2, divided by 5, divided by 5. Okay, yep, it's all good. Okay, so I'm taking out the 5, and I'm going to take out the negative. So I have negative 5, cube root, and whatever's left over. So 2 times 2 times 5. So that's 2 times 2 is 4. 4 times 5 is 20. Now I'm going to do the same thing with my x's. So I have 4 x's, but I circle a pair of 3. So that means I'm taking out an x and leaving an x inside. So this is x cube root of x. And then with my y's, I have 14 y's. So 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm circling my pairs of 3's. 1, 2, 3, 4. So I'm taking out y to the 4th, and inside my square root is 2y, so that's y squared. Everything on the outside stays outside. So I have negative 5x y to the 4th, cube root, and everything inside stays inside, 20x y squared. That's my answer.